Hello everyone, welcome back. Today we want to talk about trig functions and unit circle. So our goals then are to understand how trig functions are defined on the unit circle and also be able to use the unit circle then to help find the values of certain trig functions. Let's take a look what the unit circle is. Here's a graph here. And so the unit circle is a circle, of course, with a center at the origin and a radius of 1. Let's come over here to the right and just draw another basic version of the unit circle. Kind of one that doesn't have as much going on as this one does. So this is a circle. I know, not a very good one, just bear with me. Okay, so the center is at the origin, 0, 0. And the radius of this unit circle is 1. So this is what's called the unit circle. So if the radius is 1, then a few important points here at these certain angles. So this point here is going to be 1, 0. This point here is 0, 1. This point is -1, 0. And this point down here is 0, -1. Okay. Now, let's make an angle here in the first quadrant. Of course, it could be in any quadrant, but just simpler do it here. Okay. Now, if you have a point that's actually on the unit circle, x and y, and it turns out if you're on the unit circle, then x is the same as the cosine of theta, and y is the same as the sine of theta. Okay, and that's the value of the unit circle. Is if we're a point on the unit circle, the x-coordinate on the unit circle is the cosine of that angle, theta, wherever you are, and y is the sine of that angle. Okay, so from that, then we can actually understand the unit circle. Actually, having a unit circle like this, we can actually easily find the trig values of certain common angles, and that's what we see here. So basically, these are the most common angles. A lot of these angles are either angles that are on the axes themselves, or angles that are essentially based on those special triangles, the 30, 60, 90 triangles, like pi over 6 and pi over 3, or the 45, 45, 90 triangle like pi over 4. And so we also have these in radians and in degrees. And so we can actually easily pick out what our values are. And actually, one more thing, the equation of this unit circle, which is listed here, I was writing here as well, is x squared plus y squared is equal to 1. And that's not a coincidence, because you can actually make a little right triangle anywhere, essentially a reference angle with theta. And of course, this is your y, this is your x. And essentially, then if you think about the Pythagorean theorem, this length here, this radius is 1, x squared plus y squared equals 1. That's where that comes from. So it's connected to that. And you can think of this as consistent with the idea of reference angles. If you have a unit circle, then we can actually skip doing reference angles, just go straight to this. Now, so this gives us then for each x and y coordinate you see, it gives us the sine and cosine. Of course, then we can find the reciprocals, cosecant and secant, and then we can also, through these relationships, I'm not sure if we mentioned these before, but tangent is sine over cosine. That's true everywhere. That's an identity. And cotangent is the reciprocal, cosine over sine. So from just knowing the sine and cosine of these angles, we can find any of the rest of the trig functions. So let's take a look at some examples of this. Let's see, I'll just say find the trig functions. I mean, let's say find them all for each one of these. Find the trig functions for number 1. Let's do 2 pi over 3. Okay, now 2 pi over 3, let's take a look at our unit circle. Actually, it might help to enlarge this a bit. I can do that. I'm going to do one more click so we can see it a bit better. Okay, so 2 pi over 3, that's the same as 120 degrees, and it's in quadrant 2. Now, typically what you have to do is you have to find the reference angle for that, and then find all those values. But in this case, we can skip that since we know right away that cosine of 2 pi over 3 is -1/2. And actually, let's do it below. So if that's true, then this tells us, this implies, of course, that secant of 2 pi over 3 is going to be -2, the reciprocal of this. Sine of 2 pi over 3 then is the y coordinate at that point, which is the square root of 3 over 2. And this implies that cosecant of 2 pi over 3 is going to be 2 over the square root of 3. And if we rationalize that, multiplying the top and bottom by the square root of 3, top and bottom by the square root of 3, this becomes 2 times the square root of 3 over 3. Okay. Now, tangent, I have to do a bit more work. Tangent of theta, or tangent of 2 pi over 3, which is theta. But this is also the same as 120 degrees. So if say this is variable cosine of 120 degrees is the same thing. Now, what we have to do here then is we actually have to do a little more work, as I said. So tangent is sine over cosine. So that's the square root of 3 over 2 divided by negative 1/2. And of course, we do that, then remember, if you divide fractions, multiply by the reciprocal of the denominator. So it's the square root of 3 over 2 times negative 2 over 1. And so that's going to be, the 2's will cancel out. That's going to be negative square root of 3. And then that tells us then that cotangent of 2 pi over 3 then will be reciprocal of that, negative 1 over the square root of 3. Well, it's going to rationalizing. Multiply the top and bottom by the square root of 3. That's going to be negative square root of 3 over 3. And so that way, we can find all the values of the trig functions just by using the unit circle for these angles. Now, of course, not all angles will work that way. These are just selected angles. So if it's not one of these angles, if you know a point in the unit circle, you can also find the trig functions that way. Okay, number 2. This time, let's do negative 3 pi over 4. Okay, notice that's negative. So let's find a coterminal angle. Let's find specifically a positive coterminal angle. And the way we do that is we add 2 pi to it. So negative 3 pi over 4 plus 2 pi. Okay. And of course, we need a common denominator. So we need to put this over 4. So multiply the top and bottom of this by 4. And so we have negative 3 pi over 4 plus 8 pi over 4. And that's going to be 5 pi over 4. Okay. So let's find 5 pi over 4. And that turns out to be here in the third quadrant. And so remember, coterminal angles have the same values of the trig functions. So actually then negative 3 pi over 4 comes all the way over here. So it's coterminal with this one. And so we can do, let's just do cosine of, sine, and tangent. Negative 3 pi over 4, just pick that out right away. That is negative square root of 2 over 2. Sine of negative 3 pi over 4, which is also the same as sine of 5 pi over 4, is equal to negative square root of 2 over 2. It turns out to be the same value, in this case, this quadrant. And then tangent of negative 3 pi over 4. Well, use the fact that tangent is sine over cosine. And so this is going to be negative square root of 2 over 2 divided by negative square root of 2 over 2. In this case, that's easy. That's just positive 1 for this value. Okay. And from this, then you can also find your other values. Okay. Let's see. Let's look at another one. Now, let's actually look at an angle that's a little bit different this time. One that's actually on angles we haven't looked at yet, and one that's actually on the axis. Let's look at this time for number 3 pi over 2, which of course is the same as 90 degrees right here. Okay. So we do it the same way. All right. So the cosine of pi over 2, which is the cosine of 90 degrees, is the x coordinate, which is 0. Okay. Let's go and do sine next. So sine, and we'll talk about a couple more. Sine of pi over 2 is the y coordinate, which is 1. Okay, let's go ahead and do tangent. Actually, before we do tangent, let's talk about um, these. Okay, cosine. Now, what happens when we do this? Well, cosine, if we do secant, it's reciprocal. Reciprocal of that is 1 over 0. If you remember, 1 over 0 is undefined. Abbreviate that, so that's undefined. Remember, undefined means it's not a number. This is not defined. Now, sine, if we do cosecant of pi over 2 versus 1 over 1, which is just 1. Now, let's do tangent of pi over 2. That's sine over cosine. That's 1 over 0. That's also is undefined. Now, but what about cotangent? Well, cotangent is a reciprocal. Of course, it's a little hard to think about the reciprocal of something being that's undefined. But let's remember that cotangent in general, so if tangent is sine over cosine, cotangent is cosine over sine. So cosine over sine is 0 over 1, which is 0. Okay. So this also allows us then to find the values of trig functions that are on the unit circle or that are actually on the axes. And we may not talk about that much. Okay. Let's do another one. Let's do 7 pi. Now, if you notice 7 pi is not on there. So we need to find, let's find, in this case, find the least you need to find a coterminal angle. And also let's find the least positive coterminal angle so we can find it on here. So find the least positive coterminal angle. Remember what that means is essentially we just keep subtracting pi over 2 until we get to something that's in our unit circle. Okay. So we have 7 pi minus 2 pi. That's 5 pi. Okay. Not there yet. Keep going. So then 5 pi minus 2 pi. Subtract another 2 pi from that. That's 3 pi. Okay. Still out there. So let's subtract another 2 pi again. So 3 pi minus 2 pi is equal to pi. Okay. That's our least positive coterminal angle. So what this means, 7 pi, essentially, if we start here and go around this 3 times, so 1 gets us to 3 pi here. We get around again, it gets us to 5 pi here. Then once around again, it gets us 7 pi. Okay. Now, let's find our trig functions for pi, which is the same as for 7 pi. So cosine of 7 pi. Okay. Same thing. That's the x coordinate, which is -1. That means that the secant of 7 pi is equal to 1 over -1, which is -1. Okay. Sine of 7 pi is going to be the y coordinate, which is 0. And as you expect, then we do cosecant the reciprocal of 7 pi. That means that's 1 over 0, which is undefined. Abbreviate that. Okay. Then tangent of 7 pi is cosine over sine, or sine over cosine. So 0 over -1 is equal to 0. And then that means that the cotangent of 7 pi is equal to 1, is equal to cosine over sine, or -1 over 0, which is once again undefined. So, and the only time you have angles that are on ones that are trig functions undefined if you're on one of the axes. Okay, let's do one more approximation. In this case, let's actually go to Desmos just a minute. I'll pick kind of a random value. I can also graph circles on Desmos, which is useful. So if I just type the unit circle, x squared equation plus y squared equal to 1, okay, that's the unit circle. Let's zoom in a bit, okay. Now, let me pick out a random spot on the unit circle and just get the x and y coordinates. Okay, that's good. So I have 0.42 and 0.908. Okay, let's pick one at random. Now, let's go back then. We'll show if we can do the same thing. Okay, so this is be number 5. So for a point, say this. So for point, 0.42, 0.908 on the unit circle. Okay, let's find the values of our trig functions. Well, let me make it look a bit better. So 0.908, then, right. So the same way, if this point's on the unit circle, which we saw that it is, now that some theta, okay, let me actually draw a picture this time. So what we have, so this point was about right here, I think. Okay, so there's some theta that goes through. Okay, we don't know what the theta is, but we can find the trig function. So the cosine of theta is going to be the x-coordinate, 0.42. The sine is going to be the y-coordinate, which is 0.908. And then the tangent, theta, is going to be then sine over cosine. So 0.908 divided by 0.42, and I'm just using my calculator, or use Desmos, which you prefer. I'll just use my calculator. So 0.908 divided by 0.42. And tangent, in this case, is approximately, I'll go to 2 decimal places, 2.16. I like that better. So 2.16. Okay. Now, if we do the reciprocals, the secant of theta is going to be 1 over 0.42. Let's find that. And that's approximately, what's in 2 decimal places, 2.38. Cosecant of theta is then 1 over 0.908. Let's do that. And that's approximately 1.10. And then finally, cotangent of theta is going to be either do it as 0.42 over that or 1 over that. So 0.42 over 0.908 or is 1 over 2.16, however you want to do it. And that's going to be approximately 0.46. Okay, good. So we see how we use, now we learned how we use the unit circle then to find values of the common angles, also values of the trig functions on angles they're actually on the axes themselves. And also, if we know a point on the unit circle, we can also find the trig functions of that point that reference that angle, even though we may not know what the angle is itself. Thank you. Have a good day.